Vi har ljud.
Nu går ljudet, vänta.
Ljudet går ut. Gör det? Nej, inte nu. Jo. So welcome to today's lecture. In the software architecture class, it will be this 8th lecture after the technical problems last week. I believe that it seems like everything is working today. So today's lecture will be about enterprise architecture, one of the more important areas where architecture plays an important role. What we're going to talk about today is something that sits in between IT management, software architecture, and software systems. So it's about the mix or the place where all these areas meet and blend into one. So what we're going to talk about is really the fact that we build systems, we implement systems, and these systems are always situated in some larger system. So if we build a system, well, it might be a system that is deployed on a web server, in a web container. That means that that system is situated within this larger system. And if you look at it from the enterprise level, from an organization, for instance, like the university, well, we have many systems that together all aim at the same thing, and that is to enable the quality at the organizational level. So now we have to, before we move on into enterprise architecture, we have to to look at what this architectural level means. Well, if you have your company here, and that company, well, has some kind of business. And that can be a medical service, it can be some kind of business service, or it can be a legal, or it can be an official authority, for instance, managing visas or passports or whatever. Well, this business has customers. And these customers, they approach the business and communicate. But in order to fulfill the actual business here, there is always a back office or a back end with supporting services. And these supporting services, well, they support the business processes that the customers interact with. So, enterprise architecture is really about considering not just a single software architecture for a single system, it's about the whole package. So, starting with the applications and information, that is really where we work most frequently. But we also, when we design our applications, consider the infrastructure. So we talked about a couple of examples where you're supposed to discuss, well, the type of infrastructure you will deploy on. So for instance, last week in the lecture about the cloud, that is an example of some infrastructure mechanism that you could use for your applications. And you can also use it for your information, which is another very important component for any type of system. Okay, so now we have two building blocks or levels here. We have the infrastructure that enables our applications and our information, enables the functionality provided by our information, but also takes care about the storage, retrieval, etc. of our information. But coming back to this organizational aspect, well, again, we have the example of the university. We'll come back to that. Or we can take any other, we can take the visa authority, for instance. There is some kind of, sorry, that was the wrong way. There is a couple of levels above that our applications and the infrastructure support. There is an organization, that means like people allocated to different groups, and there's also the business processes that you see as a customer. So let's move on and look at the university. University, well, from your perspective as a student, you can approach the university through a number of services. So for instance, you can apply for courses, you can manage the admissions process, you can register to courses, you can do many different things, and underneath that level there is the university organization and a number of supporting applications and of course information. And at the very bottom there is an infrastructure. And this infrastructure spans the range from email, web servers, networks, etc. So all these levels make up the enterprise architecture. And the enterprise architecture, well, what's important here is really that when you design the system integrity was important. The reasons why we make architectural decisions is that we would like all the subsystems to relate to that overarching decision. On the enterprise level, Well, we have these systems of systems, which means that if you would like these systems to work smoothly together, you need to make some decisions about the enterprise architecture, and these decisions will then enforce certain restrictions on the systems that make up the enterprise systems. So the definition here, an enterprise is made up of many interacting systems of various kinds. The architecture identifies these systems, the properties and the relationships. And the reason why is that we need to take care about our decisions with respect to evolution and change of the IT infrastructure at our organizations. So if we, for instance, decide to make a change to some system, well, there will be dependencies. And if we have an enterprise architecture, well, these dependencies will be known, which means that we can consider effects of a decision on beforehand. So we can actually take preventive actions in order to avoid problems when we introduce a new system, for instance. So, moving on. My Moodle. This is like the starting point for most students. You enter it via your launchpad on Student LNU SE, and you come there and, well, you do things. You access your courses, you submit your assignments, you send in questions to teachers, you communicate with your peers, etc., etc. But which systems are involved in this system, My Moodle? Well, first there is a single sign-on. You sign on, and that sign-on is the same for all university systems. There is LADOC because My Moodle automatically retrieves admitted students and sign you up for a course within the My Moodle system. What else do we have? Well, we have the system itself, the web application. We have the web server on which this web app sits. And we can continue with a database. There is a backup server somewhere. There is an email server for sending messages. You know, you guys, you could subscribe and get a daily update, or whenever someone posts a news item or whatever, you will get an update. So there is some relationship to some email server somewhere, some dependency. There are also other external systems like LNU Play, which, well, we don't use here, but it could be used by in other courses. So, enterprise architecture. Well, what you see here is that there are a number of systems that existed when someone decided that we're going to use Moodle. We're going to develop our own instance of Moodle, and we're going to call it My Moodle, and we're going to deploy it on our web. When they made that decision, they had to take into account that some of these systems that existed will either provide or require things from the My Moodle system. So just the fact that LADOC, for instance, has been around for decades. You had to come up with some kind of plugin so that you could retrieve data from LADOC and use that data to feed Moodle so that you automatically registered your admitted students to courses. And these decisions are architectural decisions. They are important for this my Moodle system. So, but they are decisions that will have an effect on more than one system. That's why we need to explicitly deal with the enterprise level. So, there are two parts of it. When you design a new system and when you evolve a new system. When you design a new system, you have to take into account which systems do exist in my current enterprise architecture and how do I need to relate to them with my new system. The second one is that hopefully you have something that is stable, something that is working, and you want to change something. Say that you want to change your email server, your SMTP server for sending emails. Before you do that, you would like to know which systems will be affected by this change. Second, what type of effects do we need to deal with on these systems? Third, do we need to take any preventive, corrective maintenance to these systems in order to maintain a stable environment? So, reason about these decisions. We talked about this, make decisions on the architectural level. Now it's about making decisions one level up, the enterprise level. So to some extent it's same, but it's still somewhat different. So if you move on, we can look at some definitions here. You saw the four levels of enterprise architecture in one of the previous slides. There are some different names, but most definitions, they have 4 or 5 or possibly 6 types of architecture involved. From the open group here, they talk about a business architecture. They talk about a data information architecture. They talk about an IT architecture, and they talk about the application architecture. So they don't really have this organizational level that I mentioned before and that I have on the previous slide. It doesn't really mean anything, because if you move on and look at the business architecture here, what Open Group has in there is that they actually have the organization as part of the business architecture. So this level is very important because it defines the type of services an organization provides. And that can be the processes that creates value, that creates revenue for your organization. A university, well, we don't really have direct revenue in terms of money, but in fact, the fact that a student registers, signs up for a course and registers, generates money to the university. So this business process, register to a course, if that doesn't work, it will cause a lot of problems for the university and of course also for the students. So this level is extremely important. If you look at the My Moodle system, what are the key business processes there? Well, there are in fact 2. One level, it's the student interaction, that you guys can access material, that you guys can communicate with students, teachers, teaching assistants, etc. You can get your assignments graded, you can resubmit, well, all various tedious things connected to coursework. From a teacher's perspective, the business processes are not the same. They're slightly different. From my perspective, or from our perspective, it's more about administrating the course, setting up the course, distributing material, communicating with students, of course, grading, collecting assignments, grade the assignments, register the grades, bring out the grading reports, and move them to another system. So what you can see here is that the business architecture has to take into account that there might be many stakeholders, more than one, and each stakeholder has a set of business processes that are not necessarily overlapping. Okay, so business architecture. This is business modeling. Most companies do this to some extent. Some companies do it a lot, others don't. But the reason why they do it is that they would like to know what creates revenue. What is creating value for them and their customers. Second, they would also like to use it to develop, to evolve their businesses. In order to support your business processes, there are a couple of things that are important. The first level, data and information architecture. What data, internal or external, with respect to the hosting organization, is needed in order to support the business processes that are part of the business architecture. And this level, the data information architecture, describes data information at two levels, a logical level and a physical level. So it's concerned with the type of data, but also how the data is stored and retrieved. If you look at my Moodle, well, there are a couple of important things here. User account information, student registrations to courses. And what you can see here is an example, or two examples really, where enterprise architecture plays a role. Do you think that the user account information is stored entirely inside my Moodle? Some parts are. There is some user in Moodle representing you, but for different various usages, for instance, when you log on to the system, it uses information, user information from a different system. And the same with your registrations. There is some representation that connects your user in Moodle to the courses, but that information is synchronized, or I should say, should be synchronized with a central LADOC student study data system. So at the enterprise level, there will be several applications that use user account information for logging on. You remember that we had a single sign-on process. There will be more than one system that uses data from LODOC. So what's important at the enterprise level is to see to that all systems that are using data or possibly writing data to these shared resources do it in the right way. And it's also, of course, important that we don't change this shared resource without considering the effect on the systems that are dependent. So one example, what happened right before Christmas? That was an example of an enterprise level change where they replaced LODOC 2 with a new version, version 3. What happened? Well, after several months of preparations, actually years, this project started. And they started by closing down the existing system. And then one big effort was about migrating data from the old system to the new system. And in parallel, there were a number of system projects dealing with interfacing with the new version. Make sure that my Moodle was up and running with the new system. But there was a problem. There was a small glitch in this transition, not on the student side, but on the teacher's side, which meant that students could access their LODOC data, whereas teachers couldn't. So at some, I think it was like a week, 2 weeks, it was not possible for teachers to register any data. No data with respect to courses like grades and so on, because that was something that wasn't anticipated when the change project, the move from 2 to 3, was planned. So just, well, that small example, well, not small example, but that example illustrates how challenging this is. Moving on, the third architecture, IT. This is a software or middleware infrastructure. And what you have there is a set of supporting, I would say, for instance, for example, web servers. There are email servers. Those are supporting core applications, applications that are core business applications. So having a system like my Moodle without support for email notifications or sending emails from the application, well, that would be optimal. So you have a system supporting my Moodle with that service. Sending emails is not part of the university core business, but it's a prerequisite for a smooth operation of our business. Okay, the fourth and final one, the application architecture. So this one is more concerned with what applications are running on our system and the interactions and the relationships. So you could think of this as a first level breakdown of all software systems supporting the university's business processes. And for the My Moodle business processes, you can identify a subset there. Okay, so why do we need this? Why do we need enterprise architecture? Well, there are some primary reasons, and that is, well, today's businesses are so dependent on software. If you move back 25 years, the only system that was up and running at the university that had anything to do with students and their courses, that was Ladoc, one of the first versions of Ladoc. And that version was running at one of the Swedish universities, and then all other universities had a client that accessed this centralized server. So there were no content management systems, there were no web servers, there were actually no emails. Emails came in the beginning of the 90s, so say, well, 25 years, you know, I'm getting old, but say 30 years ago instead. There were, in fact, almost no people that were sending emails. So at that time, the IT department was two guys helping the departments with the PCs and Apple machines that students used for word processing, more or less. That was it. Now we have a completely different situation, and a problem here is that the university has grown its IT, its enterprise architecture. And that growth has not always been very well controlled. And this is pretty common in old businesses moving into something compared to a new business that establishes something. When you establish something, you can do it right from the first. But when you move into something, you have to be much more careful, not doing wrong or doing things that affect the system. And that problem, what you can see that when you evolve is, of course, that you introduce some fragility into the system. That means that you do things that solves a problem, but it creates a technical depth that you will suffer from in the future. So we need enterprise architecture to make the right decisions, to avoid technical depth, to preserve system integrity as we introduce new systems and as we evolve our current enterprise architecture. Okay. If you do the job right, you will actually get a better business. If you think about your IT support for your businesses or your business as a core asset, and you introduce the enterprise architectural level, and you can start to discuss, you can start to reason about, you can start to negotiate before you change, and you can use it to govern change, well, that will be a technical advantage that eventually also give you a business advantage, because your IT operations will be much more effective. You will not do things that affect your business negatively. And you will also introduce or change things more efficiently, which means that you will reduce cost. If you do this right, you will have a more smooth integration of your systems, which means that you can more easily provide support for new businesses within your organization. So even though that enterprise architecture level is a cost, it's worth the effort. Because without that level, your IT system will go out of control quickly. And that means that your businesses will not create any value to you or to your customers. And that means that your revenue streams are affected negatively. So how do you do enterprise architecture? Well, in fact, it's not very different from any other type of architecture work. A design, an evaluation, an evolution. Well, think about the architecture design problems that you have dealt with in this course so far. That has been a description or a vision of a system to be, of a system to be built. If you have such a vision, you can design a system that is a realization or supports that vision. You did that in the first assignment by creating a first level breakdown where you allocated responsibilities to various subsystem components. You were asked to motivate why you allocated responsibilities to various subsystems. Later, we talked about architecture evaluation. So, before you made an architectural decision, you wanted to make certain that that was the best decision given the circumstances. You do the same on the enterprise level. Is it worth the investment of millions of Swedish kronas into purchasing new system, new hardware, new licenses, consultancy services? Is that optimal for our business? Does it pay off in terms of creating more revenue or reducing our fixed cost structure? Well, that is important to include in your decisions before you decide that, okay, we go for that technology, or we go for that, or we outsource this payroll management to this company, because in fact, having them doing that for us is much cheaper than us doing it in-house. Architecture evolution, to continuously have a process where you improve, where you change to meet new business processes that are installed in your organization in order to stay on the market. This is very important. You can just look at the there have been a couple of old retail companies that have found it extremely difficult to move from a bricks and mortar structure where they have physical stores where people go in, buy their clothes or buy their whatever, and then go home, to what just happened the last 2 years, where people spend more time in front of their computer ordering clothes or shoes or electrical appliances or whatever. And not all organizations have been very successful in moving with the change here. So you see that some of the old companies, they are struggling. You could say that that is partly an enterprise architecture problem, because these guys didn't anticipate this and develop new business processes. So some companies have been very reluctant to change a successful business structure, and of course also the supporting IT systems. And that means that they have been, so to say, left behind compared to many other younger companies that built something new with a fixed cost structure which is really low. But if you want to do something where you change your architecture to meet new businesses or to meet changed business processes, to introduce new technology or whatever, what's most important is that you manage implicit and explicit dependencies so that you don't mess things up. Not just on one level, but in fact on all levels. Your business processes, your organization, your data application, your infrastructure, all levels that are relevant for your enterprise architecture must be managed during change. So how do you do that? Well, this is an overview of a process from the Open Group that focuses on how to develop your enterprise architecture. And it starts here with a vision, and it ends here with managing the changes that are needed to meet the vision from this iteration here. And there are a lot of steps in between, as you see. But they are common sense steps, I would say. We have a couple of architecture levels here that needs to be considered. And they all together depend upon and generates requirements that need to be managed in here. And then at some point we come to a evaluation and decision making. And when we have decided something, we have to see, okay, how should we implement these changes? Migration planning. And then we need to govern, see to that our decisions are implemented, and also be certain that we manage the change during the implementation. So, a simple process for something that is very complex, as always. So the development method here is, as you see, iterative, but it's also possible to run several of these intertwined. So you can have several cycles here going at the same time. What's important is that this process always have the economical perspective, and it always has the business perspective when it comes to the decision making. That means that it's not just up to us, IT people, software people, whatever, to make the calls. We always focus on optimizing for the business. And we always have this financing, this cost structure that is important. We talk about investment. And if we can't show return on investment, well, it's not very likely that we are allowed to run our change project where we install some new fancy infrastructure, whatever. The business decides. And this is actually somewhat neglected in our educations today. It's not something that we talk that much about, but in fact, you're not allowed to do many things in industry today if it doesn't create value. So if you can't motivate why you should do something by, well, reducing cost or creating revenue or value or whatever, well, typically you're not allowed to do it. So architects dealing with enterprise level, they have to be quite good at this financing projects, reason about value, etc. They also have to be very good in presenting and convincing upper management that this is actually something where they should invest their money. And then, of course, they should also be able to understand a business process, what it is, its connection to support from various applications and information, and of course, the infrastructure level. So working with ADM is kind of challenging because you have to be a little bit of everything, a jack of all trades. Okay, my friends, before we move on into the ADM and its details, I suggest we take a 10-minute break. So see you in 10. Okay, so I have to move on and see what happened here. The architecture development method, we talked about that before the break. Generic one, used by enterprises, that's not a big surprise. What's important here is that it's generic with respect to sectors or industry. It works everywhere. There are other examples that are more sector industry oriented. For instance, the Department of Defense in the US, they have a specific framework for managing enterprise architecture, etc. But the objectives for this method is to guarantee the integrity of your enterprise architecture. In order to start somewhere, you must start with a vision, because with your enterprise architecture you always have a current state, and then you want to move somewhere. You want to move to something, to somewhere where you believe that your business or your businesses are better off, that you provide better support to your customers, or you provide better services, or they are more efficient, or the costs are lower, or you can speed up your development. There are so many different things that contributes to enterprise architecture, and you need to come up with some kind of vision. Why? Well, if you want to do this, you need to finance it. So you come up with a vision, we want to do this. And you can show that this actually contributes with new business value, or it reduces the fixed cost structure, whatever. Well, then you can find a supporter. Someone who supports or champions your architecture change project, finances it so that you can actually do something. So that's the purpose of the architecture vision. To come up with a document that the higher levels of management can use to make a decision, a business decision, if this is worthwhile or not. So, why do we do this? Well, we do this because we want to improve our business. And we all know that our businesses, they is constantly under some pressure from, in this example here, there could be different trends. So there is a trend now that people shop more using internet than actually moving to the stores. That's a trend. And that affects your business. That affects the model of the market that you work on, or where your business is placed. So what you need to do as an organization is to continuously improve your capability. That is what you as an organization can do. And you need to develop a platform to support your products and services. And down here you have your enterprise architecture, among many things. So, develop a target business architecture, means that these trends here, they force you to move in some direction. And that can be a vision, part of the vision. We would like to move the business architecture in a direction where we go more for digital than bricks and mortar. So you describe a new business environment, new product, a new service, or whatever, and then all the other things connected. So the objective for this business architecture document is actually really to define the gap between where you are and where you want to be. And that's like your enterprise architecture project. So how do you model business architecture? Well, there are so many things that plays a role here, and it depends a bit, of course, where you would like to be. But it can be very simple. It can be a very simple description of a business process, or it can be a complete business model with all offerings, with a fixed cost structure, etc. You could use the ISO standard here because you have the concerns here, you have the stakeholders, and you have, in this case, a business architecture viewpoint. There are some examples where you model business processes using UML, activities, use cases, and also classes can be used. You can model an entire business model, for instance, using this canvas here. What you have here in the middle are value propositions. And then you maintain different types of relationships with your customers using channels. So you can have a multi-channel relationship with your customers. You can sell over the internet. You can sell via stores, etc. And you do that to address different customer segments. This side here creates revenue, money. But in order to support these propositions here, you need resources. You need stores, you need warehouses, there are key activities like logistics, etc. And for the logistics, for instance, the warehouses, maybe you have key partners. Partners that you partner up with, and they help you with these key activities or provide you with key resources in order to support your value propositions. However, even if you own your resources or responsible for the activities, or you have partners, there is a cost structure. So you will not get revenue for free. There is always a cost associated with it. But you can use this to model your business quite easily. And you can use it to model a new business or a transformed business compared to what you have today. So, we move on because most of you know class models and so on. But you can use the class model to model a business domain. And this can be seen as a transition into the information architecture. Because in order to understand your business, if you understand classes in that domain, well, that could represent users, it can represent products, it can represent, well, different types of offerings, channels, relationships, everything more or less that you see in the business canvas, business model canvas on the previous slide there. So you can use this to organize and better understand a domain. And that connects then into the information systems architecture. Here we look more at the data. And is data really a problem? Well, I was talking to a guy he works for the one business unit at IKEA. And he told me that just managing the products, there are many products, and there is lots of information associated with these products. There are assembly instructions. There are safety or precaution documents. There is geometry describing the product. There are other types of product material descriptions, etc. And then a company like IKEA has so many products and they are on so many markets that if you want to use this data to print a catalog for a specific country, well, you need to associate data about the country, if the product is in that country or not. And it could be that you need to change your safety instructions depending upon the country. It could mean that you have to modify your product description slightly, your assembly instructions, etc. So something that seems very simple can be extremely complex. And in fact, if you go out to really large organizations, often you don't see this common information model. They avoid that because it's so complex. Instead, they create these silos where each application is responsible for its information. But then you create another problem, of course, and that is the connection between the silos, that if some piece of information exists in more than one silo, well, there needs to be some kind of synchronization. So if you change it once, it should change everywhere. But it's important to remember that this is not about designing a database. It's a structure on a higher level. So it's not about schemas, it's higher up. Okay, in the ADM, they mix information and application. So if you think about application level in one of the previous examples, well, here they have the application system, and that is something that is necessary to support the businesses by processing data. Again, it's not about designing the applications themselves, it's about defining the type of responsibilities or capabilities we need from these applications. Okay, so we move on now and we come to the technology architecture. And the technology architecture, what is that? Well, that is the infrastructure. And here they also include the software infrastructure, middleware, support systems, etc. And identifying the technology, well, we start with the business process. We move on with the data and the applications to support the business process or changes to the business processes or new ones. Then we look at, okay, these applications, this data, do we need something on the technology level, or can we just move on? Here's a list of things that we need to consider. Now we have, on the business level, a gap. We have an architecture where we want to move from this business model to that, supporting possibly a new business or a modified business. In order to do that, we need to provide support for these new business processes with these applications that processes this data. So we have a clear understanding about what's needed on those levels, and we also thought about the technology level here. So we have a pretty decent understanding about what we need. So now we can move on and we can start to reason about things that are very important when it comes to the fixed cost structure and also the running costs. For instance, should we buy or should we build? Should we lease, rent? Several really important decisions. And given that we know what's needed at these levels, we actually have sufficient information to start reasoning about this and also to make the decisions. And we can do this on system level, software level, hardware level, all levels. And at this level, you don't just consider to get the system into your building. It's the cost to get the system into your building installed, configured, tweaked, up and running. So when you make your decisions, you decide that, okay, this guy we're going to buy, this guy we're going to reuse, this guy we're going to lease, this guy we're going to outsource, etc., etc. And suddenly you have a complete understanding, or a more complete understanding, I should say, about what's going to change. If you outsource something, well, you create dependencies that goes outside your organization. Such changes need to be managed in a specific way. But what you can do here is that you can start analyzing the change. And at a very high level, you can start thinking about, like they did when they moved from LODOC 2 to LODOC 3, how should we migrate from where we are to where we want to be? On a high level. Well, that could result in a couple of migration projects. So what happened here when they planned the migration? Well, first someone decided that this was a prioritized change. But they also started to plan how this should be done. And it was not just technical. There were also lots of procedures, documents, instructions that had to be updated. They had training days for staff. The administrative staff, they had several training days. For teachers, it was more a couple of hours. So planning this migration project was not just about, well, we install, we feed the new system with the data, and that's it. No, there's much, much more to it. Because we want to be more efficient, we want to stay efficient during and after the change, so that we don't get this typical dip in the efficiency, because that is cost. That affects the overall revenue of the company or the organization. So when you plan your migration projects, well, what you need to do is that you have to see to that all the decisions you made will be followed as these migration projects are executed. And what you do is that you formulate these as instructions to see to govern that your intentions are followed. And this can be formulated as contracts, but it's something that has to be monitored, typically by an enterprise architect that monitors the project and sees to that these contracts are followed. So, change management. When things change, what happens? Well, it's not just our system that changes. There is a constant. You remember the mega trends here? There are, of course, also micro trends and new systems, new versions, new technology being deployed. And as an enterprise architecture, you have to stay alert, on alert and monitor it and see if you can do something that improves your enterprise architecture. So, monitor your business environment, monitor developments in technology, and then provide support for architecture visions, the starting point of this ADM, and decision support for the management. Because when is it worthwhile to initiate a new architecture evolution cycle? Well, that is a result of possibly changes in the business environment. We must do something. Or a technology change. Well, it could be worthwhile to do this because it will improve this and that. But it's also a little bit more than just monitoring the change from an external perspective. It's always, of course, that you need to manage your dependencies, inter and intra. So if you have internal dependencies within your own enterprise architecture, or you have external dependencies to external systems. For instance, if you host your system at AWS, or if you host your system over at the payroll company or whatever. In the middle, I think you remember that in the middle there was a blob called requirements management. All the activities in the ADM either feeds or generates, changes, manipulates requirements. So you need to have some kind of central source here. And especially, remember now that in some cases we're running parallel ADMs. We're running several change projects. Well, if we make decisions down here after evaluating a couple of alternatives, could well be that, well, the effects of a change is not known until that point in time. And an effect can actually be that via some dependency or dependencies, some other system is affected. So the requirements management can be considered as a centralized information source. Okay. You've seen this picture before. Of course, we have software patterns also at the enterprise architecture level. Several patterns that are known also as design patterns or architecture patterns can be found at this level. One such example is the enterprise service bus. So what is the enterprise service bus? Well, integration is always a great challenge at the enterprise level. Integrating all these various systems into a whole, that's a challenge. So if you have an enterprise service bus, that's like a bus where you, via certain adapters, can plug in, connect, integrate your applications. And that pattern, well, typically builds on top of a publish subscribe pattern at the architecture level, where you have independently deployed components that subscribe to events that other components publishes. So when you work at this level, there are a set of patterns that you must know in order to be efficient in your role as enterprise architect. Enterprise architecture, these frameworks here, they are slightly different, not just when it comes to the levels of architecture, but also which architecture roles that you have within your organization. And at the top, most companies have enterprise architects. And that can be a handful, and there can be some hierarchical organization between the enterprise architects as well. Really large organizations could have, well, somewhat in the double digits, maybe possibly three-digit numbers, so 100 plus. But we're not talking about thousands here. We're talking about a rather small group of people that are responsible for the enterprise level. Then we have domain and we have solution architects. There are other examples, of course, but I just show you these three from this decomposition of architect roles. So the enterprise architect is responsible for this enterprise architecture solution for the entire enterprise. Typically, they talk more about capabilities within the enterprise, capabilities that support the business layer. Some organizations, they have a lot of business people in here too, but you often see that these guys, the enterprise architects, they are IT people with some understanding of business, but business development occurs somewhere else in the organization. So the guys here at this level, what they are looking for is what is needed in terms of applications, in terms of information, in terms of infrastructure to provide the capabilities needed by our business organization. The main architect. Well, in this course, you have been asked to think about deployment, to think about security to some extent. There are many of these concerns, and as I said, you cannot be an expert in everything. In some areas, qualified people are needed. So, security, for instance, infrastructure, data and information architects, integration architects, these guys, the domain architects, are specialists in a rather narrow field or related to a concern, more or less, or a set of concerns. So for instance, it can be performance engineers, it can be security, or performance architects, sorry, or security architects. Then we have our solution architects, and they are more generalists. I would say that they know their business or what type of business support their system provides, and they also understand the technical level. So their responsibility is to be the bridge between the business and the technical architecture. So I would say that this is maybe a more challenging role compared to the others in terms of ability to talk to different communities, to be involved in meeting with customers, etc. And of course also communicate this back into the technical organization. So that was it for today. There's a final message, and that is really, is this needed? I often hear this. Is this needed? And I would say that yes. Most companies of some size, they consider their enterprise architecture as something very important for the success of their business. And there's actually money to save, revenue to create, if you do this in a structured way. If you think of your enterprise architecture as an architecture where you can make decisions based on observations and evaluation of alternatives with respect to the benefit to your business architecture or other architecture. And at the end of the day, what it's all about is actually to manage dependencies between the systems so that you don't mess things up. Don't forget that something is dependent on this when you plan to change it. Because if you do that, you can see degradation in your business, and eventually systems will fail. And failed systems means lost revenue. So guys, that was it. On Thursday, the plan is that Mauro will come and talk to you about service orientation. He will talk a lot about microservices architecture. We've gone through the technology in the room, so it should be up and running. So we keep our fingers crossed that things are working well on Thursday. And until then, have a nice day.